Okay, everybody. I thought I'd harp on another element of statistics that I've already touched on, but I just want to really drive this point home about effect size and power. A lot of what we do in statistical analysis is look for statistically significant differences. But something that also needs to be considered is the effect size, because it is possible to have a statistically significant difference between groups, but the effect size is so small that it doesn't really matter. So it's almost like, well, yeah, it's true that there is a difference there, but who cares? So that's why you really do want to know what the effect size is, and different statistical procedures have different ways of calculating effect size. But in any case, we want to know what the effect size is after you do the analysis. So we know A, is it statistically significant, and B, what is the effect size? But also, it's a good idea to guess what the effect size is going to be before you run your experiment, because that helps you decide how many subjects need to be in the experiment to have sufficient power to find a significant effect if one exists. And so I thought to illustrate this point, I would draw three pictures of an experiment, and just take a look at these three pictures and ask yourself, which one do you think has the biggest effect size? In other words, which one of these pictures is it most obvious that the groups are in fact distinct? And I think what you'll see is that if your means are close together, that says 5 and 6, if you can read that. If your means are close together, even if your standard deviations are relatively small, there's a lot of overlap there. And that would be a rather small effect size. Then if you look at this, your means are far apart, your standard deviations are the same, and there's clearly two different groups here. Then, here the means are the same distance apart, but the standard deviations are bigger, and again, you can see there's a lot of overlap. The way this is calculated mathematically is pretty simple. You just take one mean minus the other mean and divide it by the standard deviation, and that gives you the effect size. So keep that in mind as you're reporting your results, but more importantly, as you're planning your research, you want to ask yourself, well, for example, I think there will be a big difference between penile tumescence amongst sexual predators or pedophiles versus normal people, so I would expect a large effect. Consequently, I don't need a huge sample size. Okay.